I'm Martin, and maybe one more level of introduction is that Gyula and myself had the pleasure of working on the Flink streaming API back in the day around 7-8 years ago, and more recently we founded the Flink engineering team around 2.5 years ago, joined by Matyas, who had already very strong experience with Cloudera architecture and made it possible for us to fit Flink into the Cloudera platform. And a bit over a year ago today, Eric joined us via an acquisition from Eventador, where they have built a cool platform on top of Flink, and primarily around streaming SQL, and we'll be discussing that. So let's start with a short demo / shameless plug of our product. I'll keep it shallow just to give you a bit of context, and then we'll proceed with questions and open discussion around how we see streaming SQL in production. So hopping over to the console. So this is our product, and obviously, as it is built on top of Flink, you can navigate over to the Flink dashboard for any running job. I happen to have a job running, and in the background you will see the usual Flink job. But let's see how the experience looks like. Obviously, when you have a SQL first experience, you need to have a SQL developer-like environment. So let's create a table, and let's play with this a little bit. I'll create an orders table. And obviously, if you are familiar with Flink DDL already, this will not be news. I'm using the Faker connector that is publicly accessible and contributed to the community. So let's create a table like this, and let's actually also select from this. This is basically a nice data generator approach that we often use. This in turn submits a Flink job to the cluster. We'll be able to see that it is running in the background. We can accumulate logs, metrics, and so on. And we have the output here. So as you can see, these are generated orders. And one of the things that is missing from these orders is, for example, the product name and the inventory that we have for each product. And that is a fairly common case that we see within our customer base. They often have additional tables that they want to join this stream against. And in this case, one of the things that we have added, and I want to show you, is we also have the ability to add external catalogs in this system. For example, for Hive, Kudu, and so on. And in this case, I have added a Kudu catalog, and via that, we load all of the tables from Kudu. And for the sake of the demo, I just so happen to have a Kudu table that has the product names and the inventory for these order IDs. And based on this, we get to write a streaming query that has a small temporal join that looks up the inventory for each product. The most recent inventory, I kept the logic simple. This is just the most recent inventory without looking into specific timestamps and trying to get the best case scenario. I'll get a random name just to make sure that I don't step on previously running jobs. And this will make it so that based on the data that I have stored in an external system that is more like a batch storage, I get to join that against Kafka. And you can see on the screen that now I joined on product ID, and I also have the inventory coming up. That's something that I didn't have in my original data gen table. This product goes beyond the very brief functionality that I have shown you. For example, it has ability to automatically detect schema for a from a Kafka topic, so it makes it easier to actually be able to create a table or be able to create materialized views. But the purpose of this session is more a discussion, so I won't go into detail. If you want to check this out, you can actually download it for free. I'll give you the link in the session. And also there is a full talk on the product tomorrow at 11:30 PST. So with that, let's continue with the general discussion. As you guys could see, we have led with the authoring experience because we think that even in production, ultimately production means that we should be able to very efficiently be able to submit jobs and also be able to operate and manage them. So even though the session title says production as the main marker, we believe that starts with the authoring experience. And I would like to ask Eric, what do you think in your experience is the most important to be able to efficiently author streaming SQL jobs?
Thanks. Yeah, no, and I think your demo was a good lead into that too. The great thing about SSB, in general, and Flink more, kind of more specifically, is being able to plug it into multiple data sources. But when we talk to customers about their pain points and what they're trying to achieve, 90% of the time or more, the pipeline starts with we have a bunch of data in Kafka and we're trying to do something with it. Whether it's enriching it by joining it to something else like you did with Kudu there, or even just building what amounts to be kind of a simple ETL pipeline to start off with. And if you're already using something like Avro across the board, and you have a schema registry, where you have a repository of schemas that you can reference, it's pretty plug and play. For people that don't, especially if you're using, most people come into this, they're using JSON. There's no schema associated with it, other than kind of the contract that they have with the data and the software that they wrote. One of the most important parts of the authoring experience right from the start is just being able to to describe the data that you're working with. So yeah, to kind of extend your shameless plug for SSB, I think one of the most interesting things right off the bat is the Kafka table wizard. You can start off with any Kafka topic that you don't know about. Point at it, detect a schema, and through some amount of inference, start to explore the data that's in it without having to know what it looks like before you start. It gets people to the whole experience of select star from table to just to see data coming back and start to iterate on it. And naturally over time you kind of tune that into what you what you want to see. Features like input transformations I think are important there too. Frequently the data that you have in Kafka isn't what you want it to look like in the end result. You need to be able to to mutate that data on the way in. Maybe you need to normalize things that have unexpected data in it, or you want to you want to strip out something that you don't want to make it into the final view of the table, nulls that shouldn't be there, or transform some specific field.
And also we see a lot of nested data structures. That's one of the things that, for example, you have been working on with a couple of customers that was pretty interesting to me specifically, that you would expect that, of course, let's say this is in JSON or Avro or something similar, where you would expect that people know the structure of their data, but why should they? And then the product needs to help them, or whatever solution that they are using to actually be able to figure that out.
I mean, to me, this whole wizard-driven experience was a bit odd at first, because I'm coming from a Java oriented world. I mean, even swallowing SQL itself was a step in my learning experience. But Eric, do you see any like transition from like the pure Flink DDL towards like a wizard, or is there somewhere in between, or do these things live like completely separately from each other?
I think the direction that it's going is really cool, because you start to get the best of both worlds. Like in some cases, being able to use raw DDL to to create a table and describe the data, just like you've done in a relational database for 20 or 30 years now, is super powerful. But in some cases, you really do in the scenario that Martin described, where you've got this complex data, in many cases you're generating that JSON programmatically. You didn't describe the JSON structure at all before you started. You just you maybe serialized a complex POJO into JSON, or you've just the application is kind of you've iterated on it over time, and now you have this fairly complex structure. Having to create a table with that manually by hand and describe that is super challenging. So like I think that's where like the sometimes weirdness of the wizard interface works out well, where you can just say figure out what the data looks like and give me a reasonable table to start with. But then being able to say describe that table and get the DDL that you generated from that, so that you can either modify that and then create similar tables or similar views of that, and iterate with it over time. And then at that point you can use that programmatically, like in scripts and other things, and ultimately you've used the wizard to get to the point of having that DDL. You didn't have to author it in the first place, but now you can store it in your Git repo. You can version it just along with the rest of the software.
Cool. To continue down on that path of authoring, Gyula, how often do you see that there would be pipelines with a pure streaming mindset, or is it that common that we also join with batch? And what are the usual pitfalls of such a job?
I mean, I would love to have purely streaming pipelines, but I think realistically, what we see from our customers who are coming from a more batch-oriented background and trying to transition to streaming, I mean, it's very often the case that they have data storage systems that store enrichment information that people need to use in their streaming applications, and it's simply not viable to move like pure streaming. So maybe they have some data in Hive or Kudu or HBase. So yeah, I think these join. So the cases where people mix streaming data and join it with batch data, at least for enrichment, or in some cases, even more complex scenarios. I think that's the more common than not. Yeah.
We often hear the term lookup when it comes to this. Are there any difference to lookup strategies, implementations? Is there any caching involved? How do these usually work if you call them from SQL?
Yeah, so in Flink SQL or in streaming SQL in general, there are a few different join strategies when it comes to joining different streams of data and also joining streams with batch data. So in Flink, we usually talk about temporal joins when we're joining against a table or against a specific version of a table. And one specific case, which is, I think, super common, is what we call lookup join, which is a temporal join against the latest version of the batch table. So in the short demo that Martin showed, we had the orders table, which contained the streaming orders, which had the order ID or product ID in them, and we had a lookup table for the product metadata. And in that case, we want the lookup join, where we want to kind of fetch the latest product information. It's not strictly speaking like temporal join. I mean, it is, but it's not the hardcore version of it where you can join in to arbitrary versions. It's always the latest. So there, it kind of ties back to your question regarding caching. There we can actually play some nice tricks to improve performance by caching parts of the lookup table. Yeah, and this is, I think, done quite nicely in SSB with the support of the Hive and Kudu catalog. It covers a big chunk of the use cases that we see from the industry.
Cool. Now continuing with the industry use cases and in general how this ties into a data platform, what are other components? Matyas, could you tell us, based on your experience with the Cloudera data platform, what are other tools that we see customers use in production with Flink? How do you make this an enterprise-grade platform?
Yeah, sure. So you already showed us a Kudu catalog and a join between the Kafka stream and a Kudu lookup table, and it's pretty common. HBase is used in a similar way. Both distributed database works in observed mode. So when you define a primary key in a DDL, then the messages are being updated if you insert them. So both for storing analytic query results and also for the lookup scenarios, Kudu and HBase is used quite a lot as a serving layer for downstream applications. Hive is widely used as well, and not specifically just running the Hive queries over the distributed data, but also the Hive metastore is a central point of metadata administration, data discovery, and so on. And in Flink, you can use the Hive metastore as the persistent catalog. So we have also implemented or integrated Hive with our Flink solution. And we have other catalogs as well, mostly read-only to access the Kudu tables, schema registry, and we have a few additional integration between the CDP components for security, for example. So for perimeter access, we use the Apache Knox to provide SSO functionality and also identity mapping between the centralized identity system to the cloud roles. For example, we also have integration with Ranger for authorization. Ranger protects the end systems, basically in Kafka, Hive, Kudu, and so on. And for storing lineage data, we have Atlas integration in the platform. And of course, CM plays a central role to configure and manage all these services all together in a centralized console.
Thank you. Well, one of the challenges that arises if you look at a SQL system is we now can introduce a new type of audience, and I think this ties into one of the questions that we just received, who doesn't necessarily know how to interact with a system like HBase or Kudu, or they don't have the usual tool set, so they don't have the data engineering background. And we actually have a suggestion to bridge that gap. And Eric, could you tell us about that? Why did you come up with materialized views?
Yeah, sure. Yeah, so one of the one of the core I think, I don't know, impedance mismatches with streaming, for lack of a better description, there is that with modern tools like Flink and distributed log like Kafka, is that I think it's gotten super natural to emit events from from applications, logs from applications, state from applications into this into the system, and then do something with it. Initially the data stream API, today tables made it super natural to be able to consume those those events and do aggregates and build a state picture of that information. And that's super powerful. But the end result of that frequently is that you want to build an application on top of it, whether it's ultimately there's some end consumer there that's human. It's a mobile application or a dashboard that can't consume those millions of events or the state picture on top of it. And you need to be able to have what looks to be kind of those traditional query semantics. You need to be able to ask a question of the data that gives you a picture of that data at any point in time. And that was kind of how materialized views arose. If you're a longtime relational database user, the term materialized view has a pretty specific meaning to you. And building that on top of the stream, kind of gives you the opportunity to say, at the end of the stream, we're ultimately gonna have a state picture of the thing that's occurring that's constantly upserted. That you can say, tell me what the end of the stream looks like right now. You can it'll have the same sort of query semantic as your traditional database did. Select something from a table. And filter it down and ultimately have that picture in time. And that makes sense if you're building a dashboard. Maybe you're even using some sort of third-party software. You want to build graphs with Grafana to visualize a business case. Specifically in our use case, there was kind of an early decision to use the Postgres engine as a source of the materialized views. For a number of reasons, but kind of specifically because there's so much third-party support for the Postgres wire protocol. So many things become plug and play at that point. There were some favorable indexing strategies that we could use to make that really plug and play. Where we want users to have access to these powerful endpoints, but we don't want to add that DBA experience to the streaming pipeline. We want that to be very self-service. And we want ultimately for that materialized view to be described by the streaming query as much as possible, but still plug and play into these third-party endpoints.
Yeah, I think self-service is a key expression you use there. That I think describes materialized used very well. One of the things that, coming from a background where I have been working with customers for a couple of years, was that as soon as you make it so that a single person can accomplish a task, it gets done so much faster. And the things that you would have seen previously is you have an initial result, you show it off to some project manager, and then they need to allocate people to actually work with you who know how to crack open HBase. That is gone. That is now gone with this solution, and I think that's very powerful for this reason. Actually, let's take a question, since this is an interactive session anyway. So Ingo asks us, how important is the interoperability of SQL and other APIs? For example, he points out the data stream and the table one in our experience, and are there any particular pain points? Gyula, would you take a stab at this?
Yeah. So there are two sides to this question. So first, like, how important and how well does it actually work if you're gonna do it? Well, the second one is easier to answer because that's kind of clear. I think the interoperability is really good between the data stream and the table or SQL API at this point. So there have been a lot of improvements over the last few releases, and we also use this in the implementation of our platform. So I cannot really say anything bad about that. Regarding the question of like how important it is, well, I think it's difficult. I would, if I were to write a production streaming application, I would probably still use the Java API directly or the pure SQL in itself. I think at this point, most people either know Java very well or they know SQL very well. So the mix is, I don't think it's that common, or the overlap. So I think the interoperability comes more into play when you're building like platform like solutions within your company, where you're kind of trying to open up Flink to other business analysts or SQL developers, but you still want to kind of get more access to lower level functionality that the data stream API provides.
Yeah. Gyula, do you think that building a library of UDFs is maybe one way to kind of bridge the gap between data stream and tables?
Yeah, absolutely. I think I think people don't use the full extent of the capabilities that are in Flink SQL that would be like opened up by like these nice UDFs. So I think absolutely.
Yeah, and just to look at it a bit holistically, I think roughly it's a fair point to say that maybe 70-80% of the jobs that we see in Flink could be written as a SQL job, especially if you factor in UDFs. And then there is that, let's say, 20% where you would really need to do something more clever from the data stream API, and then you can do that fairly well. And overall, I think it's a fairly common pattern, as Gyula pointed out, that you write, let's say, a streaming ETL type tool where you wire in the baseline, and you want to make it so that users can configure a small portion of a job. Let's say they should be able to add the filter or an aggregation or something else. And previously we have seen, and that's also why the Flink community itself has been pushing SQL, we have seen a lot of alternatives to that. How do you do that? Do you come up with a DSL that looks like Python, or just a JSON file or something like that? And SQL seems the best bet overall.
I think the simplicity of SQL is a bit misleading in some cases. I mean, you mentioned that or a big majority of jobs could be written in SQL, but I mean, that doesn't really mean that I would put that into production. I mean, still there is a limit to like how much you can change a SQL job that is still compatible through the save points. So I think Flink has a long way to go to really enable these SQL applications in production. I mean, not the fire and forget type of queries, because those are great, but the ones that you need to keep running over like months or years, fixing bugs, changing, like adapting to changing requirements. I think that's still a big weakness of the current streaming SQL architecture.
That's fair, but just to tap on this overall, how do save points work with SQL jobs? Does that apply to Flink SQL as well, the things that we are used to from the data stream API?
Yeah, the overall mechanism is the same. So you can take save point and checkpoints. They work for failure recovery, but the problem is that since the SQL engine or the translation logic controls the operators and the pipeline that is generated, the compatibility between save points is not guaranteed if you change your SQL statements. While in the data stream API, you can always kind of do your best to maintain compatibility. So pretty much the same, but without safety, I would say.
Yeah, I know that you like the explicit control over your code, so point taken. Actually, now that we hook into more of the operational aspect, one of the very important points that we should talk about is how do we collect logs and metrics in a production system. Is there anything special there when it comes to SQL jobs? Matyas, could you give us an overview about that?
Yeah, absolutely. So collecting logs and metrics from distributed systems is not an easy question after all, especially if you have long-running jobs that can potentially run forever and never stop. So you have to solve of gathering the logs and metrics on the fly. But fortunately, we have some well-established stacks and solutions for that, centralized logging and metric systems like Graylog or ELK Stack or Prometheus or Datadog for metrics. And the only task you need to solve is basically how to ingest the logs to these systems. And a simple log4j appender comes handy in these cases. So for example, in our stack, we solved it, both the metrics and the log collections by storing them into Kafka and then processing from Kafka using either our own implementation in Flink or a Logstash, for example, to ingest the logs and forward it into Elasticsearch for searching and monitoring purposes. So the best way to solve both is to use already running centralized components within your company, and if case needed, then tailor it a little bit for your needs. These are well-defined APIs and de facto standards, so shouldn't be a problem after all.
Can these be also integrated with alerting solutions, like, for example, PagerDuty or something similar?
Yeah, most of these monitoring systems has some sort of alerting mechanisms. So Datadog, for example, or you can even do this in an ALK stack or Grafana. So alerting usually comes together with metrics. So if any of your counters hits a critical value, then an alerting is usually fired off. So, and then whoever is on duty gets an email or any other type of notification.
The lucky one.
Yeah. I have some experience with that. So yeah, it's hard to get up at 3 a.m. and see what's going on in your production system.
Well, you can just look at Eric. He practically got up at 3 a.m.
Yeah.
Thank you, Mátyás. We received another question from Ingo, so let's continue with that. He asks, is the migration topic, and I assume he means the data stream to SQL migration based on when he asked this, is the only blocker for running complex jobs in SQL, or are there any other major issues? So one of the things that Gyula mentioned, I think right as you asked this question, was that in SQL you don't have the explicit control of how your operators will look like. Of course, that's one of the things that a declarative programming language masks from you. And also you don't have all the functionality. So if you wanted to build let's say a complex windowing logic with a trigger that is based both on count and time, those things are difficult in SQL. Is there anything else, guys, that you would call out on a high level? Gyula taps out. Keep on the good questions, Ingo.
I think to add to that just briefly, I think about the only blocker. I mean, I would say that one thing that's great about it, just to kind of add on to what Gyula was mentioning earlier, is the great thing about the stack is that you do have the option to use both where it makes sense. Gyula mentioned like explicit control over code, and Martin, you use the word declarative, and I think that those are super important in a lot of streaming applications. and you know, earlier we kind of talked about, you know, making this more accessible to other users in the business. And I think this is like where that crossover point really occurs, where there are some things where naturally you would end up, you know, you would build these things, you know, using a declarative sort of, you know, language. You'd write it in Java or Scala. You deploy that using your same, you know, CI/CD pipeline that you've always used. You treat it like any other code that you deploy. And sometimes you'll do that because there's already business logic that you want to reuse in those streaming jobs. Or you think about those jobs differently. But the great thing about having you know, the combination of this and, you know, something like a distributed log along the way is that, you know, you can take that first step. You can write this, you know, declaratively you know, built job to handle that first step. But then you can build n number of streaming SQL jobs on top of it. You know, you can reuse that stream, you know, n number of times and make it accessible to other users in the business.
Sorry, guys, I need to drop in the. I hate to cut you off, but I just.
That's all I had. Cool.
Yeah. Thank you. Okay.
Yeah. Thanks.
Thank you, guys.